All right, let's take a look. First off, warm up. As we take a look at this one, I told you the first problem, all I'm looking for is a sketch based off of your leading term here, and in this case, the positive 2 is your y-intercept, okay? So in this case, I'm gonna go through and put down, there's my y-intercept right there. And the fact that I have a positive 7x to the 4th tells me what's the graph gonna look like in general. It's a W, yep, opens up because it's a positive 7, and anything with an x to the 4th either looks kind of like a W or an M. So in this case, could look something like, I don't know, there's one possible example. The reason those blanks are there is because I did not want you to have to worry about the x-intercepts or any of that kind of stuff. So it doesn't really matter how many, where they are. I just was looking for the general shape and the y-intercept. Okay, so there's one portion. The next part that we're taking a look at is relating directly to what we're doing today. Okay, we are going to talk about long division today. So as we go back and just do some basic division, the concepts here are going to relate to what we do in the lesson. So when it says to list all the factors of 27, we've got 1, 3, 9, and 27 as our factors. 1 and 27 or 3 and 9. Okay? Then when it says to divide 27 by 2 and write it as a mixed number, here's the idea. 27 divided by 2 is 13 and a half. Which, so it goes in 13 and a half times, but here's what I want you to understand about it from a little bit different perspective. 2 goes in 13 times evenly, and if you remember back to long division, you have a remainder of 1. That's where this 1 is coming from. And we put it back over 2 because that's what I was dividing by. If that was a 5, then my remainder would have been over 5, okay, or so on and so forth. We'll get to that a little bit later on. But the whole number tells you how many times that goes in evenly, and then this is your remainder in this case, okay? Remainder of 1, and we were using 2 as what we were dividing by, okay? So then if I list out all the factors of 36, this one's got a lot of factors. We've got 1, 2, 3, 4, 6, 9, 12, 18, and 36. Okay, 1 and 36, 2 and 18, and then kind of work your way through the rest of those. So then if I take 36 and divide it by 9, in this case, I get 4 as a whole number answer. Which then if we take a look at number 4, okay, why does the first one come out with a fraction and the second one comes out as a nice whole number? Because 9 is a factor of 36. 2 was not a factor of 27. Okay? So the idea is if you take a number and you divide it by a factor, you should get a nice answer. There's no remainders going on here, if you will. Okay?
Oh, yeah.
Yep.
So, I'm confused. On that one, the bottom one makes sense where it says 36 divided by 9.
Yep.
And you get 4. But the top one, I'm confused on why you did 27. Oh, it's just 13 then. 0.5?
Yeah, 13 and a half.
Oh,
Yep.
okay.
That's all.
Oh.
And like I said, what I want you to get out of this is this one has a remainder because it is not, 2 was not a factor. This has no remainder because 9 is a factor. Okay? And we could write this out when it says rewrite them as a product of factors. I could go through and say, all right, 27 is 3 times 9. 3 and 9 are factors. Therefore, when you multiply the factors together, you get your final answer. Okay? So we'll talk about that as we get into the lesson here shortly. But I wanted you to at least see this just to start the process. Okay? Next thing I want you to do is take out your practice worksheet from the other day that we were working on, the 5-3 worksheet that looks like that.
I don't know why, but that was a little confusing to me.
Yeah, we're gonna go over that one.
Okay.
That's actually why I had you take it out. So we can go over that together. There's kind of 3 reasons why I'm having to take a look at this one. You may also want that formula sheet that I given you originally. You may want to pull that blue formula sheet out as well. Only reason I say that is on the front side, it's got the different factoring, sum of cubes, difference of cubes, difference of squares. And on the back side, it's got some of the perfect squares, perfect cubes, all those kind of things. Which both of these are going to come into play. All right, so we take a look. I'm not necessarily going to go through every single detail of this one. I'm going to kind of go through 2 or 3 things, with the main focus being on finding the x-intercepts by factoring this. Okay? So first off, I know I've got a positive x cubed. That tells me that the graph is going to look something like that. Okay? I know that's the general shape of the graph. I know that I've got a y-intercept of positive 64. Okay, which obviously is way off the graph, so I'm identifying it. I'm not really going to use it when I go through and graph this. But what I want to focus on is how do I factor this? We've talked about it, but I want to go back over it again just to keep, we're going to work through the whole process. So in this case, we've got a sum of cubes. I told you on that factoring, or on the formula sheet here, on the very front side, kind of bottom right-hand corner here, okay? If I were you, I would put a little star next to 3 of these. The first one is factoring a difference of squares, and then the last 2 are your sum and difference of cubes. Okay, so I'd put a little star next to those. Those are the 3 that we've talked about. First one is difference of squares, and the last 2 are your sum and difference of cubes. Okay, so you may want to just to star those so that you know when you're looking for factoring, those are the 3 right now that we're working on. All right, so we're going to take a look at a sum of cubes here. If I factor that, we're going to go through and factor it into 2 parts. You've got a binomial and a trinomial. Okay? Binomial and trinomial. And if you remember, this is another thing you may want to write next to your sum and difference of cubes. Remember I told you the idea of how you remember the signs? SOAP. Okay, so you may want to go through and put that. That only works for sum and difference of cubes. Okay? Here's what it stands for again. S stands for same sign, meaning, since this is a sum of cubes, the first binomial is going to be a sum. It's going to be positive. O stands for opposite, therefore the next one is going to be a negative. And AP, always positive. The last term, no matter what, is always positive. So now we've got to fill in the blanks. Okay, so here we go. The first factor is, what am I cubing? What are the 2 things that are being cubed in this problem? What's the first thing I'm cubing? That goes in the first spot. What's the second thing? What do I cube to get 64? What was it, Braxton? 4. And again, if you're not sure, on the back side of this, you've got all the perfect cubes listed out for you. You can take a look. Okay? 4 cubed. So we've got x plus 4 as our first factor. Here's the nice part about a sum or difference of cubes. I'm going to now use those 2 to fill in the next part. Whatever's in the first spot, we square it. That's what starts the next factor. So in this case, it's x squared. The middle term, it's always those 2 multiplied together. 8 times 8. So we get 4x. And the last part is always the second thing, squared. 16. There we go. You just factored in sum of cubes. And that's it. That's all it ever is to identify what's being cubed and then use those to fill in the different blanks in the second one. Okay? So now if I keep the process going here, we factored, we have not yet solved. 0 product property. By the way, how many total zeros should I have on this problem? 3. It's a cubic function, so there's 3 total zeros. Well, one of them is nice and easy. This one, x equals negative 4. There's one of my zeros, which means the other 2, which should make sense, is coming from this quadratic factor. Okay? And I told you before, it looks like this might be factorable. It never is. So what do I have to do? Quadratic formula. I have to do the quadratic formula, which leads to the next thing I wanted to go over. I'm not going to do every step, but there's some parts that I want to talk about. So this, you would have the opposite of b plus or minus the square root of, if you found your discriminant, you put it in, it turns out that it's negative 48 is what you should get underneath the square root. All over 2 times a, which in this case is 2. So the first reason I wanted to go through this one was to go through the factoring. The second reason is I want to take a look at reducing the square root of negative 48. First question, if it's a square root of a negative, what am I ultimately going to have in the final answer? What is it? There's going to be an I in there. Remember, square roots of a negative are imaginary answers. So I'm going to just do this off to the side here. The square root of negative 48 is the same thing as the square root of positive 48, I. Okay? The negative comes out as an I. And now the rest of this is trying to simplify the square root of 48. Okay? Trying to reduce that down. So remember, when you reduce, what I'm looking for are factors of 48 that are perfect squares. And in particular, the largest perfect square will get you there the fastest. Okay? So what ends up happening here, turns out that this is the square root of 16 times the square root of 3. And again, I'm going to bring the I along for the ride. Well, the square root of 16 is 4. So the reduced version is the square root of, or 4 square root of 3i. That's the reduced version of the square root of negative 48. Negative comes out as an I, and then reduce the square root. So now I'm going to substitute that back in and finish this. We have 4 plus or minus 4 square root of 3i all over 2. And the last step then here to get my final answers, you notice all the stuff that's not under a square root, everything is divisible by 2. So I can divide all 3 of those and reduce. So we end up with 2 plus or minus 2 square root of 3 times I. Those are the other. So we said we had 3 total roots or 3 total zeros. First one was easy. It was x equals negative 4. There's your other 2. They happen to be imaginary. Last reason I picked this problem is because I had multiple people that were coming in on Friday or putting the multiple people that asked last week. So what does that exactly look like then? Or how does that, what does that look like when you graph it? I know it generally looks like that, but how do we incorporate those imaginary ones? Well, here's the idea. Negative 4, I've got an x-intercept. I can put that in. Normally, I've got a positive 64 here. Because that's way off the graph, I'm just going to ignore it. Okay? It's because I want you to be able to sketch this otherwise. But otherwise, here's what it looks like. It's going to go through there. Somewhere we would have normally have a y-intercept, but then here's where the imaginary part comes into play. Remember, imaginary zeros, you don't see them. They're not x-intercepts on the graph. Which means before you get to that x-axis, graph needs to change direction and go back up again. So I'm going to say something along those lines. There's your one real x-intercept. Matches with the general shape of the graph, but because the other ones are imaginary, it's got to change direction before you get to the x-axis. Okay. That makes some sense, hopefully? Like I said, 3 reasons why I picked this problem. 1 for the factoring, 1 for the simplifying the square root of negative 48, and the other 1 for the graphing.
I'm trying to look on Canvas.
For what?
The Canvas.
For what?
This. Big pictures in prison.
For what?
She's
Two,
not looking
turn
at
in my
Canvas.
homework.
She's not looking at Canvas.
You're typing away in there.
Huh?
Well, don't worry about Canvas right now. Don't worry about this right now.
Respond to my dad's text. I mean, yeah.
Oh,
Right,
so
there
now
we
you're
go.
there.
Oh, now
Okay,
we got
but
it.
then I was in Canvas, I swear.
Hey, you won't pass
For
this
now?
down to the garbage.
Huh?
For now, just focus up here.
Okay.
Thank you. So this is the idea of what's going on with your, again, and I think there's at least 1 or 2 other ones in this packet that are either a difference or sum of cubes. And from there, like I said, now you've at least got something that you can kind of work off of. Okay? I will tell you a bigger picture here. So we're going to finish up the chapter this week. We've got 2 things left, 2 ideas. One of them is long division that we're going to talk about. And really, long division is just a method of factoring, is all it is. And then we're gonna do something on Wednesday and Thursday where we move to the next one. It's actually a little bit easier. Next week, Monday and Tuesday, then will be a review day and wrapping up the entire chapter. And then next week, Wednesday, will be your chapter 5 test on all this polynomial stuff. Okay? There are, as a big picture, there are two main things you have to be able to do on this test. If I give you an equation, you need to be able to identify and find all the important parts. Can you find the x-intercepts by factoring? Can you identify the y-intercept? Do you know the general shape of the graph? Kind of like everything we just did right here. The biggest difference between each problem is how you factor it for the most part. And then the other thing you need to be able to do is if I give you the graph, can you work backwards to find the equation? Okay, so those two things, which we'll talk about as we work our way through still. And most of the stuff we've already done. Okay? All right, I'm gonna leave this worksheet alone for now. This one is due today, okay? So we went over one of the questions. I think we talked about something previously as well. Make sure you finish this up, try to get this submitted, get this taken care of. What I wanna do today though, otherwise, is go to that packet that had the warm up on it. That's where the lesson is. And I'm not necessarily gonna go through each part, but I wanna go through a good portion of it as well. So I kind of just talked about this, is you need to be able to make a sketch of a polynomial function, okay? So if I gave you this, I know you've got a cubic function with a positive a value. That is the graph right there. Okay? So there's your positive a value, looks like a cubic function. And then the next step is to kind of verify those zeros and make sure that we can find those. So step number one, remember we're finding x-intercepts, is to factor. Well, if we take a look, notice I can pull an x out of all of that, which would leave me with 3x squared plus x minus 5. If I take the first factor and do the zero product property, x equals 0 is your first factor. There's one of them, and there it is right there on the graph. But if you take a look at the other two, they're real answers, but they don't look like they're very nice. They don't cross at some nice whole number. How am I going to find the other two from this quadratic factor? I'm not going to do it on this one, but how would I? Quadratic formula. Yep. You can try to factor. Ultimately, this would be a quadratic formula problem. Here's one of the key points, one of the key parts about this. If you can get it, so we started with a cubic function, and ultimately as we were factoring, if you can at least get your factors down to a quadratic, you know you can at the very least do the quadratic formula to get your final answers. Whether they're real, imaginary, doesn't really matter. You can at least do the quadratic formula, and sometimes you'll be able to factor. Okay? That's one of the main ideas, is trying to get factors down to a quadratic. So here's where we're headed. If you take a look at this problem, notice, I'm going to just go through a few parts here. Notice we've got a 5th degree function. Okay, here's how this is going to relate to what we did before. How many total zeros do I have for this? How many total zeros would you have? Total x-intercepts. Why 5, Eddie?
Because it has to go, you just follow the things. And then
And-
it's gonna, they all have to cross. Well, no, they don't.
They don't all have to cross, but you're right that it is 5, because it's a 5th degree function.
That's what.
Yep. The 5th degree function is always, the degree is always the same as the total number of roots. Okay? So,
Oh, do you just, if you go off the, like, each line?
well, hold that thought, 'cause I think what you're thinking is where we go next. So if I know I've got a total of 5, looking, there's the graph of that function right there. How many of those 5 are real?
3.
3. 1, 2, 3. There's your 3 real zeros right here. 1, 2, 3. And if you actually look, they're all nice ones. They intersect at -4, -1, and +3. So we've got 3 of the 5 zeros, which means, by the way, What are the other two? If you can't see them on the graph, what must they be? What is it? They're imaginary, yep. So I know that I've got 5 zeros total. 3 of them are real, and the other 2 must be imaginary. So the question then becomes, how do I find those imaginary ones? How do I work my way through this? And here's where we're headed. Here's why we're adding this in here at the end. You know how to factor that? Nope. Remember all the factoring stuff we talked about? We said if there's 2 terms, you factor it as either a difference of squares, difference of cubes, sum of cubes, one of those special cases. Well, that's definitely not 2 terms. We said if there was 3 terms, it's probably like that quadratic factoring, where you put the 2 sets of parentheses down and just kind of your normal factoring, if you will. And we said if there's 4 terms, that's where you go through and use that box method. We call it factoring by grouping. Well, in this case, there's 6 terms. You don't know how to factor this, but I need to be able to find the x-intercepts. I need to be able to find them. That is where I told you long division is a method of factoring. That's where we're headed today, okay? That's the connection between what we're currently doing and where we're gonna wrap up this week, okay? So, if we take a look, I'm gonna jump through to this. So we said, how do I solve for imaginary roots? Okay, so you can find that slide in your packet here. I think it's a couple after. And there's the idea. To solve for imaginary roots, we need to use the quadratic formula. We're not going to worry about this idea of completing the square. We skipped that this year. How do we use that for a problem that we've been looking at? Well, here's the nice idea. Here's what's coming from there. Anybody tell me where these factors came from? This is still the same problem. How did I get x minus 3? How did I get x plus 1? How did I get x plus 4? What is it? I just didn't hear.
Me?
Sure.
Oh, it says product of this factor.
It is, but where do those factors come from?
They come from.
What is it? Those are coming from the x-intercepts. Remember the graph? Here's the graph. We said one of them right here.
Oh my God, that's right.
There's negative 4. Therefore, remember, it's always x minus whatever the x-intercept is. Well, if you subtract the negative, there's x plus 4. Here's factor number 2, negative 1. Therefore, x plus 1. And finally, x minus 3. That's where they're coming from. They took the x-intercepts and turned them back into factors.
Simple.
And notice, we've got times some unknown factor. The question is, what do we know about that unknown factor?
Nothing.
There's something I know. There's 2 zeros missing, which means this must be a quadratic factor. Okay? This has got to be some sort of x squared in it, because I have to have a total of 5 x-intercepts. And so ultimately, if we go through, remember in the warm-up where we said we got a remainder of 0 when we did 36 divided by 9? Well, there's some factors that I know of right now where I should be able to get a remainder of 0 is the idea. Here's where we start the long division. And I'm gonna skip through that. Here we go. So here's the process. There's the equation we started with. I'm trying to find the x-intercepts. We took 3 of them off the graph, which then we just talked about. So I'm rewriting them as factors. So since it's negative 4, that means x plus 4 is my first factor. Negative 1, x plus 1 is my next factor. And the last one is x minus 3. And ultimately, we're trying to find that last quadratic factor that's missing. In order to do it, we're going to have to go through the process of long division. And so I'm going to take the first factor, the x plus 4. Here's the problem. There's your long division over the top. I'm going to divide it by x plus 4. And ironically enough, the process, even though this looks really bad, the process is pretty much the same as the long division you learned in 4th grade. That is currently what my 4th grade son is doing right now. He is working on long division. Okay, now obviously he's got numbers. You're doing it with algebra. You're doing it with polynomials.
With letters.
So here's the first step. What we're trying to figure out, the way you start this, is how many times does this go into that? Well, the easiest part is, somebody said, what'd you say, Maddie? Or did I totally hear something just now that wasn't there? Okay, never mind then. The idea is, if I'm gonna take x, what would I have to multiply it by to get x to the 5th?
5.
4.
No, x to the 4th.
Yeah.
Right? You got 1x, if I multiply it by x to the 4th, that's what's going in here first. X to the 4th. This is pretty much a 3-step repeated process to do long division. You just did step number 1. What do I multiply this by to get that? Now we go through and we distribute. So x to the 4th times x is x to the 5th. And then I also multiply that by the 4. So I get plus 4x to the 4th. You're just taking the x to the 4th and distributing it times your whatever you're dividing by. You remember what, if these were numbers, you remember what you would do next? Remember back to your 4th grade long division? Subtract. Same thing. Now you would go through and subtract. Because this is a lot messier, rather than subtract, I'm going to add the opposite. Meaning, I'm going to put plus and then change these signs to negatives, because it's a lot easier to combine like terms, especially once you're starting to subtract negatives and everything gets a little bit messier. X to the 5th plus a negative x to the 5th, those will cancel. That's what always should happen, by the way. 2x to the 4th and negative 4x to the 4th. If I combine those, I get a negative 2x to the 4th. Remember what we did in long division? What do I do next?
Sure.
Now we bring down, before you would have brought down the next number. Now I'm bringing down the next term. So I bring down the minus 7x cubed. And we start again, just like we did at the very beginning. What do I multiply x by to get negative 2x to the 4th? What do I multiply that to get that? Negative 2x to the 3rd. There's the next part that goes up top. And again, I told you it's a 3-step process. There's step number 1, figure out what you're multiplying by. Now I actually go through and do the multiplying. We end up with negative 2x to the 4th. And then I multiply it by the 4. I get a negative 8x cubed.
I'm watching.
I know you're watching. Happy for later. Can't remember.
You wrote a little bit small.
What's that?
It's a little.
It is a little small. Yeah, it is. You'll be in luck though. I'll show you something else in a little bit. That'll help.
It's on your phone.
Mask on.
You do.
I do. Now we subtract again. And therefore, I'm going to add the opposite. Because again, it's easier to add and combine like terms than it is otherwise. So, the 2x to the 4th, those cancel out. First terms always should. Negative 7x cubed and a positive 8x cubed. When I combine those, we get 1x cubed. And once again, now we start the process over. Bring the next term down. All right, let's keep going. Now we start again. What do I multiply x by to get, in this case, x cubed? X squared. There's the next one. Multiply it through. I get x cubed plus 4x squared.
Why can't it be short division?
Huh?
Why can't it be short division?
Well, what we're doing on Wednesday is shorter division at least. So it's coming. But this is, we gotta go through this in order to get to that. So again, subtract or add the opposite and change the signs. X cubed and negative x cubed, those go away. Negative 4x squared and another negative 4x squared gives me negative 8x squared. Almost there. Bring down the next term. Go again. This time, what do I multiply by?
Oh, negative 8x.
Negative 8x, yep. X times a negative 8x will give you negative 8x squared. Multiply through, I get negative 8x squared. Multiply it by the 4, I get a minus 32x. And once again, add the opposite. Negative 8x squared and positive 8x squared, those cancel. Negative 44x and a positive 32x gives me a negative 12x, yep. And the last step, minus 48. Which means, what's the last thing going up top?
12, negative 12.
Yep, x times a negative 12. And if I multiply through, I get a negative 12x, and then I end up with a negative 48. And this time, if I add the opposite,
0. We did that to get 0?
yeah, that's a good thing. Trust me, it's worse if it's not 0.
Oh,
Which
that's
means-
not the answer, never mind.
If you have a remainder of 0, what does that mean about the original x plus 4?
Don't imagine it.
It's a factor.
It means we didn't have to do anything.
It's a factor. Which, hang on. So, that's where we're headed. Hold that thought.
I'm done.
So, what that tells me is, and that's why we were doing that warm-up, when we did 36 divided by 9 and got 4 with no remainder, no remainder means it's a factor. So what you just worked your way through is you proved that x plus 4 is a factor of that 5th degree function because you ended up with a remainder of 0. So what does that actually tell you if I go a little bit further? If I were to take x plus 4, I'm going to put it right here, and I would multiply it by what we got as an answer, x to the 4th minus 2x cubed plus x squared minus 8x. If I multiplied that out, we would get that 5th degree function back. Okay? Here's what I want. I'm going to go back for a second before we go forward. Remember back to this slide where we said we've got to go through and get to that unknown factor?
Yeah.
We just did step number 1. We got to keep working our way through in order to get to that unknown factor. Okay? Here's the good news. The example we're doing right now is almost literally as hard as it gets. We're doing like the hardest possible case. Okay? Most of the stuff you're going to do in your homework is going to be easier than what we're currently doing. Okay? I started with the worst case scenario so that anything less than that is the idea. We got our x plus 4, and right now, all of this stuff is that x to the 4th that we just came up with. Now we got to keep going. Okay, let's do one more of these together. I'm going to now take the x plus 1 and our answer and go one more time through the process just so you can see it again. And then from there, we'll finish things up. Okay? And in this case, so you might just have to do this on like the back of a sheet or something. I added this extra slide in after the fact. So x plus 1 is what I'm dividing by. And we've got x to the 4th minus 2x cubed plus x squared minus 8x minus 12. All right. And we already know that x plus 1 is a factor, so we know at the end of this, we should get a remainder of 0. If I don't get a remainder of 0, then I know that it's incorrect, okay? Same process, but now we're starting with an x to the 4th, so it's going to be a little bit shorter. Could be one whole less process of what we just did. What's the first thing going up top? What do I multiply by?
4.
X3. cubed.
X cubed. You got an x? If I multiply it by x cubed, I will get x to the fourth. And we distribute x cubed, x to the fourth, excuse me, plus x cubed. And add the opposite. There we go. X to the fourth, negative x to the fourth cancel out. Negative 2x cubed and a negative x cubed give me a negative 3x cubed. Bring down the next term and go again. This time, negative.
You forgot the 2x cubed. Yeah,
What do you mean?
negative 2x cubed.
I put those two together,
Oh.
and that's where that came from. Negative 2x cubed and a negative x cubed.
Were you on your phone again, did you?
No, I wasn't.
So now, what do I multiply by? Negative 3x squared would get you negative 3x cubed when you multiply. So take that and distribute it through. We end up with a negative 3x squared. And again, add the opposite. Okay, I'm hoping you're starting to see why I add the opposite rather than trying to subtract. It gets really messy if you're subtracting all these different negatives. It's a lot easier if you look at this as adding, changing the signs of the second one. Now you're just combining the terms. Cubic terms cancel out. X squared and plus 3x squared gives you a positive 4x squared. And every time you bring something down, you start over and go again. This time we multiply by 4x, positive 4x. Add the opposite again. This time the x squareds cancel out. Negative 8x and a negative 4x gives me negative 12x. Finally, bring down the negative 12. And the last thing you need to multiply by is exactly that, minus 12. Multiply through, I get a negative 12x minus 12. When I add the opposite, I end up with 0 as my remainder, which confirms what we said at the beginning, that we knew that x plus 1 was going to be a factor. So now, where am I at this point? In the first part, let me just go down here for now. We said we confirmed that x plus 4 was a factor. Now we just confirmed that x plus 1 is a factor.
Now we have to do the last.
And, hold that thought. You could. And a lot of times the answer will be yes, you do have to. Now we've got a cubic factor. X cubed minus 3x squared plus 4x minus 12. And so ultimately, we're down to a cubic factor. So now, like Eddie said, now the last step to kind of finish this out would be take the third factor that you already know, along with the cubic one, and you gotta go one more time. Again, it should be less, because now you only have cubic function instead of a fifth degree. But ultimately, I'm going to kind of stop there because we're running a little bit short of time, but I want you to look at something. Don't put anything away yet. If you take a look, so what I did is, this is a lesson I used from last year, and I kind of stole, Mr. Notsky went through and did the whole thing, and I just stole the pictures from him. So here was our original problem. Went through, wrote out the factors. If you take a look at the first picture, it's exactly what we did. X plus 4. Got the exact same thing that we got. There's my remainder of 0. So you've got all of this listed. Then, he took x plus 1, divided it through. There's your x cubed that we just came up with. This is literally the spot we are at right now. Here's why I'm going to this to finish out. If you took the last factor, the x minus 3, along with the cubic that you just got, here's what you would end up as. Remember, we were trying to get that last quadratic factor? So what that tells me is this. 0 number 1, 0 number 2, 0 number 3, and now you can take your last quadratic factor and solve it. It turns out, we said the last two were imaginary. There's your imaginary answers right here. Positive and negative 2i. When you finally got to that quadratic factor, going through and setting that equal to 0 and then solving it from there using 0
I
problem.
just can't believe you do
Okay.
all that work just to find.
It's a long process, okay? And I wish I could tell you that there's a simpler way or a quicker way to do it. The answer though is there's not. This is, for now, the good news is, I'm only gonna give you 4 questions. One of them's already a quadratic, one's a cubic, so there's only one that's a 5th degree function, okay? And so I'm gonna give you the worksheet for today's. Here is what you should be doing. Here's your practice to learn, okay? For going out of today, that you should be working on for Wednesday.
What